Example 2. A rectangular page has 36 square inches of print on it. The margins on each side are 1.5 inches. Let's find the dimensions of the page such that the least amount of paper is used. So, same idea as before. So, our first step, we want to draw a picture and label the variables. And so, if we do that, so let's think about a sheet of paper, right? So, here's our sheet of paper. And we know we've got 1.5 inch margins on each side. So in here is all our text. So that's our text. But then we've got a 1.5 inch margin on every single side. So all four sides have a 1.5 inch margin. And so then we're going to call our dimensions of print, because that's what we know. Let's call that X and Y. So the area of print is going to be X and Y. So a better picture now that we know what our margins look like. So if this is my print area, and so here's my X, here's my Y, then we know the entire sheet of paper is going to be X plus 3, because we have 1.5 inch plus 1.5 inches extra on the Y side, going that on the X side. And then we have Y plus 3 for the sheet of paper, because same reason, we have 1.5 plus 1.5 on each side. What do we know? Well, we know the rectangular page has 36 square inches of print on it. So we know X times Y is our rectangular region of print, is 36 inches square. Remember, units of area will always be units squared. What do we want? Well, in this case, we want the dimensions of the page. So in this case, we want X plus 3 and Y plus 3. Such that the area of the page, so the least amount of paper is going to be the area of that page, right? Is minimized. Alright, so how can we find a function and the domain? So for our function, your function's always going to be related to what you want. So we want the dimensions such that area of the page is minimized. So our function needs to be area of the page. So in this case, the area of the page is going to be X plus 3 times Y plus 3. And we can FOIL this out because it's going to make finding our critical numbers easier, right? So area is xy plus 3x plus 3y plus 9. But same problem. We need a function in terms of one variable. So we've got to eliminate either x or y. So let's use what we know. So we know x times y is 36 inches square. So then I'm just going to solve for y. So y is 36 over x. So now we can rewrite this area equation as the area function a of x equals to x times 36 over x plus 3x plus 3y, or sorry, plus 3 times 36 over x, because we're substituting in for y, plus 9. And so then cleaning that up, we get a of x equals 36 plus 3x plus 108 over x plus 9. And simplifying that, we end up a of x is equal to 45 plus 3x plus 108 over 9. Or sorry, 108 over x. So there's our area function in terms of just the variable x. So for our domain, well, what do we know? X and y both have to be positive. Y That's right, because they're dimensions, right? So we can't have 0 page or negative page length, right? Or width. So they have to be positive. So as long as x is positive, what do we know? So if x is greater than 0, that's going to imply then y equals 36 over x is greater than 0, right? So our domain in this case, and our domain, we're just talking about x because that's our variable in the function, right? So our domain then is going to be x ranging from 0 to infinity, not including either endpoint. All right, so we have our function, we have our domain. What's next? That's right, we need to find our critical numbers and test them, right? So why do we have to test? Well, if we don't test it, are we guaranteed that critical number is the type of extrema that we're looking for? No. So by testing it, that's the only way we're going to find out if that critical number, in this case, is our relative minimum. So we need to find our critical number and test it. So remember, to do that, what do we have to do? That's right. So we want to find, so we have our function in the domain. So a of x is 45 plus 3x plus 108 over x whenever we're on the interval 0 to infinity. So then a prime of x, so remember, find our critical numbers, we need our derivative, is 3 minus 108 over x squared. Set it equal to 0, so that gives us 3 equals 108 over x squared, so 3x squared equals 108. X squared equals 36, so x equals plus or minus 6. So our domain for this is 0 to infinity, so negative 6 we don't care about. It's not in our domain. So just the positive 6. Similarly, set x squared equal to 0, where the function is going to be undefined. The derivative is undefined, right? So that gives us x equals 0. Again, not in our domain. We don't care. So the only one we have to test is x equaling positive 6. That's the only critical number we have to test. So then let's do our second derivative test. So a double prime of x is 216 over x cubed. So a double prime of 6 is 216 over 6 cubed. That's greater than 0 because 6 is positive, so 6 to the third power is positive, and positive divided by positive is going to be positive. So a of x has a relative minimum, right? By the second derivative test for relative extrema. Whenever x equals 6. So now let's answer the question. So what were we asked to find? What do we want to know? We wanted to know the dimensions, right? So for our answer, so x equals 6 inches and y equals 36 divided by 6, 36 divided by x, which is 36 over 6, which is 6 inches. But keep in mind, these are the dimensions of what? These are dimensions of the print, right? What did we want? We wanted dimensions of the page, right? So of the entire sheet of paper. So remember, x and y, these are our dimensions of the print. So to get the dimensions of the page, we need to add 3 to both x and y. So the dimensions of the page are x plus 3 equals 9 inches. By y plus 3 equals 9 inches. So the dimensions of the page that we have our 9 inches by 9 inches. So in this case, our page is a square, but remember every single square is a rectangle, right? So we do have our rectangular page.